Yeah, welcome back, and let's today learn about series circuits and the potential divider. So to start by, let's start. We have a circuit here. The circuit has got three resistors, R1, R2, and R3. Then we have our supply voltage here. So as we know, current in a series circuit, as in, for instance, these three resistors are arranged in series, so current is equal in all the three resistors. Current is equal in every part of the circuit. Then the current is the same in all parts of the circuit. Then we go there, the point number 2, it says that the sum of voltage drops is equal to the total applied voltage. As you know very well, R is a resistor, so a resistor leads to a voltage drop as the current passes through. So this means that R1 plus R2 plus R3 gives us the R total. The total resistance is equal to R1 plus R2 plus R3. How do we go about it? So we've said V1, or how do we get this formula RT is equals to R1 plus R2 plus R3? So we can say V is equals to V1. V1 is the voltage at R1, voltage across R1. V2 is voltage across R2, and V3 is a voltage across R3. So V is equals to V1 plus V2 plus V3, as you can see, as you have read from point number 2 here. So this means the R total is equals to this. So how do we go about it? So from Ohm's law, we know that V is equals to IR. That is, V1 is equals to V1 is equals to R1. Then we say that the current is equal. So meaning, if the current is equal all through, it means I, that is our current, is equal to, voltage is equal to I, that is the current, then R1, the resistance at R1, that's the voltage drop at R1. Then V2 is equals to I R2, then V3 is equals to I R3. So we have V total, that is V total, V is equals to V1 plus V2 plus V3. So V is equals to IR. So it means that total voltage is equals to total resistance times the current. So if the total voltage is equals to total resistance, so that is why we have this here, that is I times RT, or R total. So to get these, we had added these ones over here. So we have IRT is equals to IR1 plus IR2 plus IR3, which is equals to, if you factor out I, you get I into R1 plus R2 plus R3, which will give us IR is equals to I into R1 plus R2 plus R3. So dividing by I on both sides, you get RT is equals to R1 plus R2 plus R3. Hope we are good at that. So we move forward to see what potential dividers circuit is. A potential divider circuit is a circuit that is used to measure the resistance at the voltage at across one resistor, having two resistors in series. So having known that, we have this circuit here. This is our circuit. You can see these resistors are arranged in series. So V in is equal, or V out is equal to R2 all over R1 plus R2. How do we go about it? For resistors in series, the total resistance here is R1 plus R2 plus R3 plus Rn. So the current is equal in each and every element. So we have V in. V in is our total voltage that is entering. So we have V in is equals to VR1 plus VR2. But we know that V is equals to IR. That is VR1, it is the voltage drop across R1. Then VR2 is the voltage across R2. So we have V in is equals to IR1, that is this one. We get IR1 because of V is equals to IR. So V in, or the voltage, total voltage, is equal to IR1, that is VR, voltage across the R1, the first resistor, then plus IR2 across the second resistor, which is equals to, here we have I into bracket, that is factoring out I. So we have R1 plus R2. So to get I as our subject of formula, we have I is equals to V in, that is the total voltage here, then divided by R1 plus R2. So VR2 at R2 here, now this voltage V out, will be equal to current I1, current I, then multiply by the resistance, this resistance R2, that is R2, so IR2. But we found that I is equals to V in all over R1 plus R2. So multiplying by R2, we find out that VR2 is equals to V out, VR2, that is the voltage across this 2 ohm, the second resistor, is equals to V out, that is V out, this one, which is equal to R, this resistance, multiplied by, or R divided by R1 plus R2 multiplied by this VI in. So we're just removing the V in outside, then collecting this because it's a light term. So thank you for watching. That's how we found the voltage or current divider, potential divider. That's how it goes. Subscribe, like, and leave your comment. Thank you.